Yeah, so I'd like to talk to you guys a little bit about a project I've been working on to, help people maybe write more easily on their computer. So just to give you an idea of what I'll be covering, I'd like to first introduce the problem of digital writing and talk about some relevant technology that already exists. I'll talk a little bit about my own experience developing a solution, and I'll show you a little bit of what I built. There are a couple reasons why you might be interested. So first of all, I'll be talking about technology. And I understand this is a technology colloquium, so hopefully some of that will be interesting. I'd also like to share my experience with entrepreneurship. It's something that's kind of hard to get a grasp of how it works without hearing a bunch of examples, so maybe I can offer one of those examples to you. And then lastly, since this is generally a pretty technical crowd, maybe some of you are still looking for better ways to draw on your computer. So maybe I can help give you help you make a more well-informed decision. Just a little bit about myself. I just finished my PhD in mathematics at Princeton. I was studying partial differential equations and general relativity. I consider myself a computer enthusiast, probably as many of you guys as well. And I've had a couple technical jobs, a number of hobby projects along the way. But as a disclaimer, I don't necessarily consider myself to be an industry expert in computer science. Yeah.
I believe I missed your name. Oh,
sorry. Yeah, I'm John Stogin. Yeah. And I also wanted to, in the beginning, thank Andy and Dennis for inviting me to come speak. Okay. All right, so I thought I would start with a quote by Steve Wozniak. I had a TV set and a typewriter, and that made me think a computer should be laid out like a typewriter and a video screen. Okay, so I thought for a little bit, what are the ways that a computer has helped us go beyond the typewriter? How does it really improve our process of typing, right? And I sort of split it into 4 categories. So the first, which is to me the most important, is you have the freedom to change what you wrote, right? Once it's down on paper, if you're typing, then it's sort of stuck there. But with computers, you can delete, cut, copy, and paste. You can really iterate with your ideas and just put the raw ideas down and work with them. The computer also allows instant communication, so you have email, chat, etc. Live document sharing like Google Docs. It also helps with storage and organization, and it can provide some form of intelligence like spell check. But there are lots of ideas that we have which are not easy to use a typewriter or a computer to express. And so then we might ask the question, is a computer better than pen and paper for expressing those ideas? And if we look at the same 4 categories that I discussed with the computer, there are actually a lot of analogous advantages to being able to use a computer for these. So in terms of changing what you write, if you're trying to solve a difficult problem, you don't want your first question to be, where on the page should I start writing this equation, right? You just want to get the ideas down and then work with them. Additionally, for doing calculations, you often end up rewriting the same things over and over, right? So if you're going from this line to this line, maybe you just move a couple terms around, 2 terms cancel or something. That's a new advantage. For communication, something maybe similar to Google Docs, but for handwriting, storage and organization is more or less the same. Intelligence, I think, is one of the more interesting things. We still don't see much of this, but there is a potential to check for errors in calculations, just like spell check, and then also even to perform calculations based on things that we write. But I leave a question mark up there because for some reason, most people seem to still just be comfortable using pen and paper. They're not really using computers for this. And so this is the way that I like to phrase the problem of digital writing, that we don't use typewriters anymore, but we still use pen and paper. Okay, so here's another quote, this time by Steve Jobs. God gave us 10 styluses, let's not invent another. So as you may guess, he's referring to capacitive touch in this case, right? So this I mentioned first because this is probably the most well-known technology for input onto a computer besides, say, a mouse and a keyboard. And definitely, if one were to think of drawing on a tablet, which seems more natural for these types of ideas, then capacitive touch might be the place to start. Just a little bit of background on capacitive touch. So it uses a two-dimensional array of tiny capacitors on the screen. The presence of a finger affects the mutual capacitance. And this is something that then can be measured and converted into some coordinates. Interestingly enough, it can detect multiple fingers at the same time. It's made popular by the iPhone in 2007. And it's very well known. There are a couple reasons why it's not very good for drawing, though. So most obviously, it usually requires a blunt object on the screen, so you can't write precisely. There's actually an exception to this. You can get some battery-powered styluses that actually have a much finer tip, but I'll get into why those also don't work very well. Another problem you have is confusing the palm with the screen. And then it has a relatively long measurement time. The amount of time it takes to actually figure out the position of something is actually too long. In contrast, there's another piece of technology, the inductive stylus, which is really quite fantastic for writing. And I'm seeing some people nodding their heads here, which is it is great to hear because I've actually learned that most people still are not familiar with this technology. But I'd like to tell a little bit about how this works. So what happens is you need a special board behind the screen that emits a localized electromagnetic wave. And then you have a special stylus that, with a circuit tuned to that wave, that will reflect it back if it's at the right frequency. And so then the board emits a localized wave, and then it switches to try to detect the reflection. And that will allow the board to figure out the proximity of the stylus. So this is used in only a few well-known tablets. So the Microsoft Surface Pro, the Apple iPad Pro with the Apple Pencil, that's what that's all about. And then I have a Samsung device here that has an S Pen. So the S Pen also uses that technology. As I will now show you, this is a lot better for writing detailed expressions. But I would like to actually go over the patent a little bit more. Or this is a patent by Wacom, just explaining how it works again. So here they have an array of coils going from left to right. The height in this diagram is actually the full height of the screen. And then there are about, say, 40 or so coils going from left to right along the screen. They're overlapping. And each individual coil, you can select one, send an alternating current through it. That will emit the electromagnetic wave. Then you stop sending the current. And then that same coil can function as a detector. And then if the stylus is nearby, it reflects it back. Something that I think is quite remarkable about this idea is you can have these, you can have a non-trivial circuit inside the stylus. And that allows you to, say, press a button on the side of the stylus or detect the pressure that the stylus is pressing on the screen. So even without having any battery in the stylus, you can have this, this functional input. OK, so going over the measurement and response. So in this figure here, we have some clock signal A. And then B is a signal that determines whether we're emitting or detecting a response. So you say take A and B, and then you get C. D would be the resonance in the stylus itself. So as you're sending the signal, then the stylus becomes more resonant. And then as you stop sending the signal, then the stylus will emit less back. And then E is measured response from the stylus, and then from there it's basically processing signal E. But E is basically what you're trying to measure, and that will give you an idea, the proximity of the stylus to the board, or to the individual coil. And then you do this for a bunch of different coils. So you repeat it a bunch of times, and then you can plot the response over all the coils, and then do some statistics on that, and you can determine approximately where the stylus is located. Actually, I shouldn't say approximately, it's incredibly precise. And in this patent, they say that it can take them about 10 milliseconds, and that is fast enough to make a pretty precise, to precisely measure where the stylus has been. Okay, so just to make things a little clearer again, so when you have capacitive touch, you have the measuring device is transparent and on top of the screen. For the inductive stylus, you have the measuring device located behind the screen. Okay, so some drawbacks to the stylus, or to this inductive stylus technology, is that, well, you have to have a special stylus, and you have to have a special detecting board, which must be placed underneath the screen in the tablet. And this, I think, is one of the main challenges to getting this technology widely adopted. If you already got a tablet, or you already have your favorite computer, then either you already have this, or you don't really have a hope of using this behind your screen. It also has a drawback of being a little bit sensitive to noise. So for some products like the Microsoft Surface and the Apple Pencil, they actually have to have some power in the stylus itself. So they can't just rely on emitting and measuring the signal. For other devices that don't, like the Samsung tablet, you notice, for example, the camera is not in the location of the screen for that same kind of reason. So some of the devices will interfere with this measuring technique. But the benefits are that you have a stylus with multiple buttons. You don't have palm rejection issues anymore because your palm doesn't interfere with the signal. And you have very fast measurement time. Okay, so I'm not going to go through all the technologies out there, but there are a number of creative technologies. I didn't want to say that this was exhaustive. Probably one of my favorites is the smart pen that uses the De Bruyne pattern. So this is a pattern that, if you look at some piece of the pattern, it's a long sequence, such that if you know a very small part of the sequence, then you know exactly where you are in the sequence, right? And so, someone had a clever idea of putting all these dots on a piece of paper, and then you have a pen with a camera that looks, and then it can just see a couple dots near where the pen is, and then it can tell where the pen is on the paper. So, okay, so here is a quick comparison of the main technologies that I just mentioned. So this is using a blunt stylus on a standard capacitive device. Okay, I have the same person writing each of these. So this is using a battery-powered stylus, also with a capacitive touch device. So if I jump back and forth between the two a couple times, you can see that it's possible to write a little bit more precisely, but unfortunately it's still pretty hard to tell what the person was even writing, okay, because they're writing too fast. In contrast, this is what you get if you use an inductive stylus. So it's should be a lot clearer to you. In fact, maybe even hard to tell that this was written on a computer instead of pencil and or pen and paper, unless, of course, you read it, in which case you know that is using an inductive stylus. Okay, so the conclusion from this part of the talk is that there is some great technology out there to help people draw. Personally, I found this incredibly useful when I was in college. I took all of my notes and did all of my homework on an inductive tablet. It was that good, and I basically never had to use paper. And I thought it was quite unfortunate when I saw that most people didn't have access to this technology. So yeah, so here's the conclusion. I would say that a computer is definitely more useful than pen and paper if you have this technology. Okay, and then I couldn't find exactly a quote on this particular technology, but I found a quote. So Albert Einstein said, "I admire the elegance of your method of computation. It must be nice to ride through these fields upon the horse of true mathematics while the likes of us have to make our way laboriously on foot." So the context here, he was talking to Levi-Civita about tensor calculus, but I think if you completely take it out of context, then it makes for a great quote for the inductive writing technology. Okay, so now I'd like to switch gears a little bit and tell you about some of my experience developing working on developing a solution to help more people get their ideas onto their computers. Okay, so again, a little bit of a personal story. I first was exposed to this inductive writing technology in high school. They had a cart of these tablets that they would bring into math class, and then we could all write on them. I thought it was very useful, so I got one for college. And then a little bit after college, I bought this MacBook Air, but really missed having the access to this technology and thought, well, wouldn't it be great if there was some sort of peripheral device that I could just have to sort of complement my laptop? So I couldn't find one for a while. I eventually got an iPad because they were pretty cool, and decided to buy like the stylus with the best reviews online, and thought, you know, maybe this will do the job. It was quite disappointing though. So then I started thinking, okay, well, how difficult would it be to make one of these things? So the first idea that I had was, all right, let's try coming up, how inexpensive could you get an inductive writing tablet to be? Maybe you strip out all the fancy things. Maybe it can't even, say, like, give you a good web browser or something. But what if it's just good enough for doing the drawing, right? That could help with costs. And then maybe you could even come up with a revenue model to help, you know, maybe you don't make money off of the device itself, but you can still run a sustained business by helping, like, people help each other, right? So you have some sort of tutoring model or something where some student is working on a homework problem, they get stuck and they press a button, and then someone else can sort of interact with them remotely. I thought this would be great. It has the advantage of helping, you know, students in some low-income neighborhoods and hard-to-reach areas. And then also it can help minimize distraction, because people now, when they're doing their homework, if they have the internet around and stuff, it can be a bit distracting. So it seemed like definitely a really fun idea to play around with. So I started trying to build one. So there's a Raspberry Pi, inexpensive computer, and then this is the guts of one of these. Inductive boards. So Wacom sells these boards that don't have a screen that you can plug in as a peripheral device, and it's very frustrating not to be able to see what you're drawing when you're drawing on it, but it's very good for if you want to get access to this technology without spending much money. As I said earlier, this technology works through the screen. So you have the detecting board underneath the screen. So you, in theory, can take this board and then just put an ordinary LCD screen on top. And so that actually worked. So, okay, so I wrote some software for it as well. Basically, try to take away everything that could be, you know, using up processing power, so you can focus on the writing. And so here's a little video example of the tablet in action. So here I'm squaring an expression, and it's a lot faster, say, to copy that expression than to rewrite it twice. Here's another little video, so showing the ability to, say, add more space at the end of a page. And then here's one final video showing how you can take, say, some ideas that you had drawn maybe very quickly and then rearranging them the way you imagine them, the way they should be presented on a page. Okay. But I quickly learned that one of the, so there's a lot of problems with this idea that I had. The first of which, and I had no idea when I got started, but building the tablet is actually not the hard part. So when you're trying to find a solution that is economically viable, there are a lot of factors that go into this besides actually just being able to create the solution yourself. And then another slightly related issue is that I knew basically no high school students. So the initial plan that I had, I basically would have had almost no way to actually go about implementing it, even if, say, I could have access to a bunch of these tablets. So I was very fortunate to eventually get to participate in one of these ideation accelerator programs. My wife at the time was a grad student at Penn State, and they had a community program for a couple people who wanted to commercialize an idea. They took me into it and gave me some good advice and basically encouraged me to abandon hardware completely. And told me to talk to a lot of people. So actually, abandoning hardware I was really, really against this, because the way I was thinking is, this inductive technology is great. We just need to get more people to use it, right? And there's no way software is going to, doesn't seem like there are many good ways that software alone could help us solve this problem. It really felt like a hardware problem. But the step of talking to people was really, really key, and I'll get into that now. But it was something that I certainly was not interested in doing, because I like to, sit at home and work on my own little problems. But it's daunting, but it's definitely rewarding. And again, part of this talk is aimed towards, if you at some point in your future decide that you want to solve a problem that other people face. So here's some practical advice for how to go about doing that. So you can tell 4 mistakes that I made when I started talking to people, because they're the 4 things I said that you should not do. So the first is hand people a paper survey. The second is to assume that you just want to convince investors that your idea is a cool one. It almost seems like that's always what you want to do, but that's not the main reason, I would say. What you really want to do is you want to have a conversation with people. And it's very interesting. I found that if you want to learn how someone is doing something currently, they're often willing to have a lengthy conversation with you, like even 30 minutes. And it seemed very odd to me that strangers would be willing to talk to you for over half an hour about something. But this is really the way that you learn how people are currently struggling with their problems. And sometimes it helps. You have to guide the conversation a little bit. But after talking to a couple of people, you start getting better at keeping the conversation in line with helping you understand their challenges. OK. Also, I'd recommend this. If you go to talkingtohumans.com, there's a great little PDF with a lot of practical advice. OK, so here are some of the things that some of the patterns I noticed when I was starting to talk to people. So a lot of researchers we talk to say they use Skype and hold up, say they'll draw something on either the chalkboard or a piece of paper and hold it up so the other person can look at it. A lot of people also complained about having to type long expressions in order to get their equation, and especially something like this, which it definitely seems complicated, but if you actually want to type that equation up, it's very complicated, right? And if you're missing a parenthesis somewhere in that expression, then who knows how long it'll take you to find where that missing parenthesis was, right? Definitely distracting when it would be so much quicker to draw it on paper.
He's a mathematician.
Sorry?
Wolfram is a mathematician, not a computer scientist.
Yeah, so I'm sure they're aware of this problem too. But this is generally what people have to do, right? They have to type these. Actually, some of my favorite complaints were and from multiple people talking about how they would be using some educational software and typing in a chat window to the other person, typing an equation, and then on the other side it comes out with some emoticon or something. So
You haven't even gotten to the 4 languages yet.
yeah.
Kanji, hiragana.
Yeah, actually, that's something I wish I understood a bit more, but
Have you talked to anybody in Japan or China?
I've talked to people in the US who do foreign language stuff.
Like at Xerox or IBM or universities? Or?
Mainly universities, yeah.
Oh, you should talk to Richard Dasher, a couple of buildings over.
Okay. Yeah, I mean, it's really interesting how like you can talk to people and you start learning the challenges that they're dealing with. I definitely would encourage it, um, uh, especially if you want to. I mean, it's very easy to look at some successful idea or some successful implementation of an idea and think that this person, either they were there at the right place at the right time, or it was really they just figured out the way to do it. But I imagine now whenever I look at these cases that there was probably a lot of this kind of process that you usually don't hear about. Okay, so besides those observations, there were a couple other observations that I started to make. The first is that universities do spend money on software. So going back to my original idea was to look at, try to help high school students, and presumably parents of high school students would be the paying customers. Here is like a group of people that I know a little bit more, right, and understand a little bit more. And then, but probably the most surprising thing to me was that 80 to 90% of the people I talked to were not even aware that this inductive technology exists. And this room may not be the best sample because, well, we're in the computer science building. But it was surprising how many people really just thought that drawing on a tablet was like drawing with capacitive touch, and it was just awful. Which, by the way, gives me hope that maybe someday this technology will be a lot more widespread, and maybe I'll move beyond this problem. But it hasn't happened yet. Okay, so here's sort of the new plan that I had after I talked to a bunch of people. I'm going to focus on academics and universities because I actually know these people. My goal now is to help researchers communicate their technical ideas over a distance. So the classic examples being, say, two researchers at two universities who are collaborating on a paper, or maybe a grad student whose advisor is off giving a talk somewhere, but they need to discuss something that the grad student is working on. And then because most people aren't aware of this hardware, try to find the most affordable solutions and equip departments with this technology so that they can have effective communication. All right, and then in 2016, there was this new program that Princeton started called the Tiger Challenge. The idea was to help teach students how to come up with creative new ideas by, again, talking to a lot of people and understanding their challenges. So I proposed this problem: find a way to make digital writing less cumbersome without needing an expensive tablet. And there were a couple of students who spent more of this time trying to identify what are the real challenges we have. And our main conclusions after this project was we decided there were three main components that go into the challenge of digital writing. There's, first of all, space. Actually, the second and third are kind of obvious. So you want to have a natural feel when you're drawing, and you don't want to spend a lot of money. OK, so that seemed pretty clear. We weren't quite aware as much of the space issue. So a lot of people expressed a desire to be able to see a lot of what they're drawing at the same time, which makes sense, especially if you're trying to solve a complicated problem and it takes pieces from different areas. You'd like to be able to see all of that. And again, we noticed that a lot of people were holding things up to a Skype camera. And so this is what got us thinking that maybe an interesting feature would be to take a picture when someone's holding their equations up or their drawings up to a camera, and then process those drawings and convert them into some sort of digital object. So here's, well, OK, so this is the first picture from what I've been building, but here's the idea. You have some drawings that are on a sheet of paper, and then those drawings themselves get processed onto some sort of board. And then each individual component, so like this equals sign is really two different digital pieces at this point. They're now these digital objects that some of them in a group can be selected and rearranged. So they're no longer stuck the way they were on paper. So this almost sounds like a really obvious solution. I tried to think briefly, like what was preventing this this from me from thinking of this earlier, and I think a couple of the reasons is that recognition, although it's fantastic, and I'm sure that in the computer science department here, a lot of people get very excited about this. As a user, if you have some special set of symbols or characters, and you're trying to recognize it, then it can be actually a quite frustrating experience to have, say, your special symbol being recognized as some other symbol. And then I also think I was I was not interested in camera-based approaches because I thought that you still have to draw on paper, and so you're still sort of stuck. But this actually seems to help a lot, especially if one person, say, has the writing tablet and they're just trying to get their colleagues somewhere else to enter some ideas, then this actually could help quite a bit. Okay, so here was the new idea. So it's very similar to the previous plan that I had. The main difference is that now we're talking about something that is designed to help people even if they don't have one of these special tablets. So assuming they have some sort of camera or something, which most people have their phones or a laptop with a webcam. And so again, in the ideal setup, if you care a lot about space and you have a tablet, then your computer screen is probably most often the largest viewing space that you have. So you can be showing all of your drawings up there, but then say drawing on a portion of it with your tablet. And that's something I can probably demonstrate at the end. But then there's also this scan feature. So if, say, your colleague doesn't have one of these tablets, they can still be inputting valuable information. Okay, so basically since we came up with that idea, I spent most of last fall and winter actually building the minimum viable product, which I think was actually very productive. I mean, this is sort of getting on a little bit of a tangent, but again, for any of you who are thinking of building something, it's amazing how much faster you can go when the whole idea is in your mind instead of amongst a couple different people. So, I mean, teamwork is definitely very important at some point, but looking back, I always wanted to form a team right away, but I think this was actually a very useful period of time to be able to work on it on my own. So that was the fall and winter. I also had to write a thesis and defend, so that happened in the spring. And then during the summer, I finally did get a team together, which I was very excited about. And that brings us to the fall. So now we're working on ironing out some of the wrinkles and hopefully having a useful tool soon. So, okay, I wanted to show a couple more screenshots of what we've been building. So this is where we left off last time. It also supports some video calls. So this was something a lot of people wanted, was to be able to see the face of the person, but most of the conversation is happening around some ideas that are on the board. So, and then also annotating PDF documents. So often if you're working on a draft of a paper or going over, say, a concept that's in say a book where you have the PDF, then this allows you to do those annotations. And in this example, some of these things were drawn using a mouse, so like the highlighting and the red, but those calculations on the right were things that were scanned in. And then, of course, some of the things that I imagine would excite people in this audience, there's, well, okay, so if you like typing in LaTeX, then you can type LaTeX equations as well. And we're just getting started on the recognition and calculation. The calculation feature is not on the live beta app right now, but some of the recognition is. Okay, so basically we've changed a little bit in our vision. We're hoping to be sort of a next generation drawing tool that includes these features like the webcam scan, but also handwriting recognition, which, again, to get back to the frustration of writing things, we imagine sort of building these packages that allow you to specify, say, if you're in a particular research subfield, maybe you can specify like what kinds of symbols belong in that package, and even how to calculate with them. So that's sort of how we would imagine these being implemented in practice. We are working to support modern browsers and tablets. And again, our goal is to help students organize and share their notes with each other, and also to help researchers communicate over a distance. And yes, our URL is scratchworktool.com if you want to play around with that at some point. Just to give you an idea what's on my mind right now. So we have a couple of our immediate concerns are managing persistent data. So we're just about settling on a file format. And the reason it's such an immediate concern is because once we start storing people's data, it becomes a lot more challenging. If you want to change something later, then you have to go through and update all of that, or have some sort of backwards compatibility. Our user interface still can use some work, as you may discover if you want to give it a try. I think we're getting there, though. And our tablet apps are a little bit behind the web app in development, but they're also making progress. Yeah, and what I would really love to do someday, if this actually starts becoming useful for a lot of people, is maybe returning back to that first vision of helping a lot of people in different areas especially students, get the help that they need. But yes, I want to caution that we have a long way to go, so I'm certainly not claiming to be doing that anytime soon. Okay, so maybe I'll conclude my talk in a moment, and I can give a couple of demos. Actually, why don't I give a quick demo now? And then, okay, so, oops. Okay, so here is the app, and I have on this sheet of paper, I have a diagram with a mistake on it. So I'm going to take a picture of this diagram and select it. So here are my the diagram sort of digitized, right? So now I'm free to, say, take an eraser and erase the part that I didn't want, and then say, select this, move it down over here. Okay, so there's a little bit of a demonstration. A lot easier, I think, to draw this first on paper and then digitize it instead of trying to do that right away. Unless, of course, you have a drawing tablet. So I'll log in and then click this synchronize button here. Now I have also a duplicate drawing screen on here. And now I can say, I don't know, circle the 1 or do some sort of calculation. So I'll do the cosine theta plus sine theta squared. I love this calculation just because it becomes quite clear that when you do these calculations, you have to rewrite things over and over again. In trigonometric functions, there's a lot of writing involved, right? So I can select this term and make some copies. And then I'll, okay, so cosine squared theta plus 2 cosine theta sine theta plus sine squared theta. And then I, of course, would like to rearrange these terms, right? So I can group these terms together because there's this nice trigonometric identity, right? So then this is equal to 1 plus 2 cosine theta sine theta. You can also add, as I said, you can add these blank pages, right? So, and then say, select things and rearrange them the way you want. All right, so that's hopefully a little bit of a demonstration of the ability to sort of more freely work with your drawings. Yeah, so I guess the main things I hope you might take away from my talk are that computers can also be very helpful for drawing ideas as well, besides just typing them. Not all tablets are the same, so I see at least someone in the audience who has a tablet that looks like it has an inductive writing stylus, so that's good. But if you are ever thinking of getting one, I would encourage you to look for the Microsoft Surface Pro, the Apple iPad Pro with the pencil, or the Samsung tablet. So the Samsung tablet, as long as it has the S Pen, that's the key. So you can buy basically an identical tablet for a little bit less that doesn't have the S Pen, and at least for this particular purpose, it's worthless. But this one is only $350 right now. The screen size is not so bad, and so it's my personal preference. Regarding entrepreneurship, I definitely encourage you, if you haven't tried it before, it's a very interesting and rewarding experience, even if it doesn't go anywhere. But if you're a techie like me, then don't expect that the hard problem is to actually build the thing. There's a lot of work involved in talking to people and understanding what the real challenge is. And then lastly, I hope you now know a little bit about what I've been working on, and feel free to play around with it and sign up for our beta. Thank you. Questions?
So what has your experience been with other people trying to use it? Because you had something in your head that was marvelous, and you went to talk to somebody, and they looked at you, and you realized they weren't reflecting marvelous back.
Yeah. So well. Yeah. Okay. So there are a couple parts. So one thing is one of the. So say if you go back to this original tablet device that I built, this was mainly, I mean, of course it wasn't, it was obvious that it's not something that someone would actually take into a class and use, because this is a big clunky thing, right? So part of talking to people is just learning, that there are some things that you take for granted. I took for granted that everybody knew about this technology, when it turns out that wasn't what they knew. But you're probably also asking about, now that I'm building something like this, what is it like getting feedback from people? And that, I mean, we're just starting to get feedback. I would first of all say that some people have used it and have told me about them actually using it to solve their problem. And that's an incredibly rewarding experience to hear about, say, a grad student who was working with his friend in the UK, and they were annotating like 7 different papers at the same time. It's very rewarding to hear that. But the real useful information that you get is generally about the mistakes, or why isn't it working as well as you would hope. And so it's, I must say, it's a bit of a daunting task, especially to get the criticisms, and then actually be able to convert that into improving the product. So we definitely have a longer list than what we've been able to get to so far. But and also some of the feedback that you get is maybe not necessarily something that you can even do, because you have to think. I mean, if say you're designing a chair, someone might say, "Oh, I'd really like it to come with a table or something," right? And you have to sort of decide, which things you're actually going to work on.
Yeah. So you showed a couple ways to kind of get stuff into your tools ecosystem, right? You can draw tablets, you can scan stuff. How do you get stuff out? I know I want to submit some homework.
Yeah, that's a very good question. So there are a couple ways, and this is still work in progress. But for example, you can select this image and then download it as like a PNG, right? So if it's an image, if say it's just something that you wanted to put into a document, then you can do that. In the live site right now, this feature isn't supported, but the whole purpose for me adding this page is that you can also convert that whole page into a PDF or print that as well. And if you upload PDF documents to annotate, then you can download or print the resulting documents with the annotations on them. Right now it's not available on the live site because there are a couple new elements that we've added that don't support that yet, but we will have that up soon. Yeah?
When you do collaboration, do you have two people connected to the same document at the same time, or?
Yeah, so this is sort of like a Google Docs model. So right now it's basically anybody who goes to the link will be able to view. And actually, this is a very good question. So one reason why it's so much more helpful than, say, using Skype and showing the other person what you drew on the paper is that if, say, I scan this diagram in and you are also looking at the, yeah, well, with Skype, yeah, you can't change it. But with something like this, then you can. So I can enter my equation, and then you can, say, delete a term that doesn't belong there or something.
What does that look like? Do you like two cursors appearing on the screen at the same time, or?
Yeah.
Oh, okay, so it's not like you have to commit or something.
No, it's very much designed to be a live process.
Can that work? How does that scale? I mean, can you have more than two people, or
Yeah.
do you
That's,
eventually go to a one-to-many for educational purposes? And
yeah, that's something that I'm sure that I would guess probably around 6 or 7 people you'll probably start having problems. So with the current implementation of it. We have to do a little bit more research and decide who we're going to target. So for example, if we want to go into online classrooms, then we definitely want to be able to support like one-to-many interactions. If we want to support classrooms where, say, multiple people can be presenting to each other, then we have a many-to-many issue. If we're really just looking to sort of help like small numbers of people, then maybe we don't care too much about, say, the topology of our network. But yeah, we will have to think about that some more in the future. Yeah?
This isn't really appropriate or really relevant to the real world, but you might be amused. There was an episode of The Big Bang Theory 6 or 8 years ago where the gang did something that sort of touches on this. When you need to solve system differential equations, write them out longhand, take a photograph of your smartphone, run that through an image recognizer, character recognizer, submit to an online solver engine, and then email you the result.
Yeah, well, that's hopefully it won't be as involved as that, but yeah, it's kind of interesting that we haven't actually. I don't think we've really gotten to that point yet. And by we, sorry.
Yeah,
I haven't actually talked to him.
Yeah, actually, Stephen has worked on this.
He has?
Yeah.
Okay. Yeah, that wouldn't surprise me.
Well, it's not just Stephen, too. I mean, the Japanese and the Chinese are working on it as well. I mean,
okay.
they've been doing a lot of cursive. I mean, their languages require cursive assistance, and they've worked on it through the 90s. Because they have serious problems with several billion people.
Yeah, we've heard also with chemistry, for example. There's a lot of interest in being able to. Sorry?
Who's chemistry?
We're not using a system. I'm just saying that there's a lot of interest in, say, being able to take chemical molecules and say, categorize them or something. There's a lot of research going into
Bell
that.
Labs developed a language named Chem, which I played with, but most chemists don't use Unix systems. And I think, my understanding, the system they use, I was talking to some of our chemists, use a system called Pluto.
Okay.
But I haven't actually seen Pluto in action. There's organic chemists and there's inorganic chemists. It's the organic chemists who really derive chemical language systems. You have to have a real serious organic chemist about that.
Yeah, we just started looking at some of the papers they've been making. I mean, a lot of a lot of what we're working on isn't necessarily like, cutting edge research into, the artificial. I would love to spend, most of my time just like trying to write a cool equation recognizer or something. I mean, it seems like a very fun problem, but it's, for us right now, it's a matter of priorities. And I would say that we'll be successful if we can take other, say if it's a system that's built on Linux, like you said, or Unix. Yeah, so if we can take some system like that and make it a lot easier for a lot of people to use, I think that would be probably our main goal.
In your timeline, you were yada, 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 then write thesis, as opposed to write thesis, yada, yada, yada. How did that conversation with your advisor go?
Yeah, that's a good question. So, well, basically, I had most of my. I had solved the final problem for my thesis. Was basically solved before the beginning of my final year in school. So I knew that I had some time to, say, play around with a project like this. And that I knew at some point I'd actually have to write everything. But if I had worked out pretty much all of the details, then hopefully the writing itself, I could have a rough guess as to how long that would take. So it was a lot of writing for about a month. It ended up being about 550 pages long. And of course, it was very nice to be able to wrap that up. But yeah, I certainly didn't put that off necessarily. I managed to get enough done early enough so I could focus on this project for a little while.
That's a smart move. Make sure you already have the solution before you commit to the
Yeah.
So did you use Mathematica for those equations?
Sorry?
Strange question. Since you do general relativity, did you do it by longhand writing, or did you use Mathematica or some other representation?
No, there was a little bit of Mathematica. I don't know if any of that really made it into my solution to the problem. It was all, I feel kind of bad saying this, pencil and paper, because I would have liked to use this, but this wasn't ready yet.
You've built the thing, you've already had so long with that.
I kept telling myself, if I can finish, well, part of it was I was hoping to have enough of it done so that I could actually like show my advisor and use it, but sadly I didn't quite reach that point. Yeah?
Any comments about the possibility of incorporating 3D constructs here?
3D constructs. Well, my initial thought, yeah, so my initial thought is I'd have to learn a little bit more like what kinds of use this would have and how many people would want to use something like that. There's always a temptation to sort of add all these different features, but first you have to think if you're going to add something new, how many people are going to benefit from it. Do you imagine like a three-dimensional plot or?
Yeah, sure. I'm thinking about, for example, let's suppose you're dealing with millimeter wave beamforming problems. Those are when you're actually crunching it out and working with MATLAB or whatever.
Okay.
You're going to typically visualize that in 3D.
Okay.
Now, often you will extract from that a projection, which goes.
Sure. So yeah, an image that could go in here.
Have that intermediate step. It's kind of helpful.
Yeah, I mean that I think would be interesting. It would definitely be interesting to include. We'd have to spend more time thinking about.
The problem you have there, though, is we would start getting into Escher conflict type ambiguity. No, really. And I mean, Ivan Sutherland, when he did his PhD thesis, was the original Sketchpad. He kept it to 2D as an example. He did not try to do very much in the way of 3D. And the simplest thing you do is just draw a cube. And the question is, okay, so what's the front face and what's the back face?
So you're talking about like recognizing, say,
in a 3D scene.
This is related to some problems that I had when I was first building I didn't get into a lot of the algorithm behind actually, filtering the image because probably wouldn't be incredibly interesting to you. You can imagine there's just some thresholding involved, but you do have these sort of you have to deal with shadows, right? And so you can imagine some contrived examples where you have something that's really dark up here, but then maybe it gets lighter. And so like if you want some sort of globally consistent drawing, then you have exactly this Escher type problem where you know, it really looks like up here it should be ink, but down here it shouldn't be. But yeah. So even those issues are even encountered in the two-dimensional problem as well.
Yeah, that's why I brought up Mathematica, because they have this interesting math aspects in 3D, multidimensional, whatever. The Einstein story. There are different representations. Since my name is Morph, I usually bring up isomorphisms, whatever. But that has to do with representations. I think I do a lot of that kind of thinking.
Okay.
And I'm trying to challenge myself doing it in multi-dimensions. And you have the math already in your head. So why didn't you push that a little harder?
Why didn't I push?
Your 2D
I see, yeah.
bitmap graphics, that's way too low level from a mathematics point of view. So you should be able to use some insight, like different coordinate system, let's put it this way.
Well, okay,
so you know about the transformation between coordinate system. Cartesian is too simple,
that's exactly
and the others
right.
are too complicated. So different representation from a math point of view might help that.
Yeah, I mean, it's at the end of the day now, since I'm trying to find something that will be useful for some select group of people, I have to figure out like how what are the typical use cases that we imagine for something like this, and then the question would be like, does something like 3D or I don't know, higher dimensional?
I think you're limiting yourself by bringing it from that end. They may be thinking the wrong way.
Maybe.
You have in advanced math concepts in there that, like I said, different coordinate systems. Maybe one coordinate system is better than another. That's actually more complicated. Cartesian is used because it's simple enough, so you can write down simple equations, addition, multiplications. But once you go to rotations, whatever, or tensors, maybe you should think about how to represent tensors. Just as an example.
Sure.
But there's a longer discussion there. I'm just going to toss out.
Sure. Yeah.
Not to change the complete drift here. There are ways of doing it.
Yeah. Maybe afterwards you could tell me a little bit more. But yeah, again, I think the problem is there are ways to do pretty much anything, right? But then we can't necessarily have pretty much every feature in say this this particular product. So we have to think carefully about what are the things that most people are going to be looking for. If you add too many bells and whistles, then people can start getting confused about how to use. But
I still think you're too low level. Given your math background, contribute something there. That's all I'm saying.
Okay.
Right now, the two are so disjoint, you can't connect them. You don't seem to be able to connect, but anyway. It's your talk.
As an opposing perspective, I'd like to compliment you on doing what you did do and actually getting something useful put together. And that counts for a lot. And it's easy for us to think of things that you could have attempted.
Well, it's also my natural temptation too. I mean, like when you see an opportunity to say use some advanced mathematics or add some really cool feature, it's definitely like that's the thing that you want to jump into doing. But I'm sort of learning just by I don't know doing this long enough now. I'm starting to see that you have to leave some things on the back burner. Yeah.
Many chips have failed because the designers were so intent on adding gimmicks they never quite got it to work.
Yeah, and I wouldn't necessarily exclude us from I sometimes worry that maybe we've already put too much in. So.
Okay. When you use this with Skype, is this a Skype client or how does
this currently does not interact with Skype. We have some. It's not perfectly working yet, but we do have embedded voice and video calling that uses WebRTC. If any of you are familiar with that API from Google and Mozilla. So currently it's sort of a standalone tool, but you're certainly not the only person who has mentioned the idea of integrating it with Skype. So that means that I have to keep this in mind.
It would be neat if, even if the full interaction is only available if they both have your client, you should it should be possible to have a Skype connection with a passive client who can see what you're doing. That is, he can't write, but he can read, and that encourages them to convert from Skype to your product after they've seen, they can see how easy it is for you, but they can't write back. So then they want to convert to your product.
Yeah, so that could be a good, some sort of marketing strategy, or we haven't really even begun to figure out exactly how we're going to go to people. Yeah?
So I'm guessing this is a typical problem. You explain it to people and everybody inundates you with their wish list. So I'll add one more to the wish list for me, which is Jupyter Notebooks.
Ah, yes. So I agree. I think it would be pretty cool to include some sort of code support. Yeah, I will keep that in mind. Yeah.
Should we use any sort of invite code when registering for the beta, or should we just put our email?
Oh, yeah, you can put your email in. The invite code is, you will get one when you put your email in, and then if you, so what we're hoping to do is as we sort of slowly, so we're hoping soon to be able to release accounts so that you can save what you're working on. And we'd like to invite people in groups so that, if a couple of people wanted to work on it together, we'd want to invite them all at the same time. So that's what the invite code is for. Thank you. Most people seem to still just be comfortable using pen and paper. They're not really using computers for this. And so this is the way that I like to phrase the problem of digital writing, that we don't use typewriters anymore, but we still use pen and paper. OK, so here's another quote, this time by Steve Jobs. God gave us 10 styluses, let's not invent another. So as you may guess, he's referring to capacitive touch in this case, right? So this I mentioned first because this is probably the most well-known technology for input onto a computer besides, say, a mouse and a keyboard. And definitely, if one were to think of drawing on a tablet, which seems more natural for these types of ideas, then capacitive touch might be the place to start. Just a little bit of background on capacitive touch. So it uses a two-dimensional array of tiny capacitors on the screen. The presence of a finger affects the mutual capacitance. And this is something that then, and then lastly, since this is generally a pretty technical crowd, maybe some of you are still looking for better ways to draw on your computer. So maybe I can help give you help you make a more well-informed decision. Just a little bit about myself. I just finished my PhD in mathematics at Princeton. I was studying partial differential equations and general relativity. I consider myself a computer enthusiast, probably as many of you guys as well. And I've had a couple technical jobs, a number of hobby projects along the way. But as a disclaimer, I don't necessarily consider myself to be an industry expert in computer science. Yeah.
I believe I missed your name.
Oh, sorry. Yeah, I'm John Stogin. Yeah. And I also wanted to, in the beginning, thank Andy and Dennis for inviting me to come speak. OK. All right, so I thought I would start with a quote by Steve Wozniak. I had a TV set and a typewriter, and that made me think a computer should be laid out like a typewriter and a video screen. Yeah, so I'd like to talk to you guys a little bit about a project I've been working on to, well, how help people maybe write more easily on their computer. So just to give you an idea of what I'll be covering, I'd like to first introduce the problem of digital writing. and talk about some relevant technology that already exists. I'll talk a little bit about my own experience developing a solution, and I'll show you a little bit of what I built. There are a couple reasons why you might be interested. So first of all, I'll be talking about technology. And I understand this is a technology colloquium, so hopefully some of that will be interesting. I'd also like to share my experience with entrepreneurship. It's something that's kind of hard to get a grasp of how it works without hearing a bunch of examples, so maybe I can offer one of those examples to you. Okay, so I thought for a little bit, what are the ways that a computer has helped us go beyond the typewriter? How does it really improve our process of typing, right? And I sort of split it into 4 categories. So the first, which is to me the most important, is you have the freedom to change what you wrote, right? Once it's down on paper, if you're typing, then it's sort of stuck there. But with computers, you can delete, cut, copy, and paste. You can really iterate with your ideas and just put the raw ideas down and work with them. The computer also allows instant communication, so you have email, chat, etc. Live document sharing like Google Docs. It also helps with storage and organization, and it can provide some form of intelligence like spell check. But there are lots of ideas that we have which are not easy to use a typewriter or a computer to express. And so then we might ask the question, is a computer better than pen and paper for expressing those ideas? And if we look at the same 4 categories that I discussed with the computer, there are actually a lot of analogous advantages to being able to use a computer for these. So in terms of changing what you write, if you're trying to solve a difficult problem, you don't want your first question to be, where on the page should I start writing this equation, right? You just want to get the ideas down and then work with them. Additionally, for doing calculations, you often end up rewriting the same things over and over, right? So if you're going from this line to this line, maybe you just move a couple terms around, 2 terms cancel or something. That's a new advantage. For communication, something maybe similar to Google Docs, but for handwriting, storage and organization is more or less the same. Intelligence, I think, is one of the more interesting things. We still don't see much of this, but there is a potential to check for errors in calculations, just like spell check, and then also even to perform calculations based on things that we write. But I leave a question mark up there because for some reason, a lot of this kind of process that you usually don't hear about. Okay, so besides those observations, there were a couple other observations that I started to make. The first is that universities do spend money on software. So going back to my original idea was to look at, try to help high school students, and presumably parents of high school students would be the paying customers. Here is a group of people that I know a little bit more, right, and understand a little bit more. But probably the most surprising thing to me was that 80 to 90% of the people I talked to were not even aware that this inductive technology exists. And this room may not be the best sample because, well, we're in the computer science building. But it was surprising how many people really just thought that drawing on a tablet was like drawing with capacitive touch, and it was just awful. Which, by the way, gives me hope that maybe someday this technology will be a lot more widespread, and maybe I'll move beyond this problem. But it hasn't happened yet. Okay, so here's sort of the new plan that I had after I talked to a bunch of people. I'm going to focus on academics and universities because I actually know these people. My goal now is to help researchers communicate their technical ideas over a distance. So the classic examples being, say, 2 researchers at 2 universities who are collaborating on a paper, or maybe a grad student whose advisor is off giving a talk somewhere, but they need to discuss something that the grad student is working on. And then because most people aren't aware of this hardware, try to find the most affordable solutions and equip departments with this technology so that they can have effective communication. All right, and then in 2016, there was this new program that Princeton started called the Tiger Challenge. The idea was to help teach students how to come up with creative new ideas by, again, talking to a lot of people and understanding their challenges. So I proposed this problem: find a way to make digital writing less cumbersome without needing an expensive tablet. And there were a couple of students who spent more of this time trying to identify what are the real challenges we have. And our main conclusions after this project was we decided there were three main components that go into the challenge of digital writing. There's, first of all, space. Actually, the second and third are kind of obvious. So you want to have a natural feel when you're drawing, and you don't want to spend a lot of money. OK, so that seemed pretty clear. We weren't quite aware as much of the space issue. So a lot of people expressed a desire to be able to see a lot of what they're drawing at the same time, which makes sense, especially if you're trying to solve a complicated problem and it takes pieces from different areas. You'd like to be able to see all of that. And again, we noticed that a lot of people were holding things up to a Skype camera. And so this is what got us thinking that maybe an interesting feature would be to take a picture when someone's holding their equations up or their drawings up to a camera, and then process those drawings and convert them into some sort of digital object. So here's, well, OK, so this is the first picture from what I've been building, but here's the idea. You have some drawings that are on a sheet of paper, and then those drawings themselves get processed onto some sort of board. And then each individual component, so like this equals sign is really two different digital pieces at this point. They're now these digital objects that some of them in a group can be selected and rearranged. So they're no longer stuck the way they were on paper. So this almost sounds like a really obvious solution. I tried to think briefly, like what was preventing this from me from thinking of this earlier. And I think a couple of the reasons is that recognition, although it's fantastic, and I'm sure that in the computer science department here, a lot of people get very excited about this. As a user, if you have some special set of symbols or characters and you're trying to recognize it, then it can be actually a quite frustrating experience to have, say, your special symbol being recognized as some other symbol. And then I also think I was not interested in camera-based approaches because I thought that you still have to draw on paper, and so you're still sort of stuck. But this actually seems to help a lot, especially if one person, say, has the writing tablet and they're just trying to get their colleagues somewhere else to enter some ideas, then this actually could help quite a bit. OK, so here was the new idea. So it's very similar to the previous plan that I had. The main difference is that now we're talking about something that is designed to help people even if they don't have one of these special tablets. So assuming they have some sort of camera or something, which most people have their phones or a laptop with a webcam. And so again, in the ideal setup, if you care a lot about space and you have a tablet, then your computer screen is probably most often the largest viewing space that you have. So you can be showing all of your drawings up there, but then, say, drawing on a portion of it with your tablet. And that's something I can probably demonstrate at the end. But then there's also this scan feature. So if, say, your colleague doesn't have, and then here's one final video showing how you can take, say, some ideas that you had drawn maybe very quickly and then rearranging them the way you imagine them, the way they should be presented on a page. OK, but I quickly learned that one of the, so there's a lot of problems with this idea that I had. The first of which, and I had no idea when I got started, but building the tablet is actually not the hard part. So when you're trying to find a solution that is economically viable, there are a lot of factors that go into this besides actually just being able to create the solution yourself. And then another slightly related issue is that I knew basically no high school students. So the initial plan that I had, I basically would have had almost no way to actually go about implementing it, even if, say, I could have access to a bunch of these tablets. So I was very fortunate to eventually get to participate in one of these ideation accelerator programs. My wife at the time was a grad student at Penn State, and they had a community program for a couple people who wanted to commercialize an idea. And they took me into it and gave me some good advice and basically encouraged me to abandon hardware completely. And told me to talk to a lot of people. So actually, abandoning hardware I was really, really against this, because the way I was thinking is, this inductive technology is great. We just need to get more people to use it, right? And there's no way software is going to, doesn't seem like there are many good ways that software alone could help us solve this problem. It really felt like a hardware problem. But the step of talking to people was really, really key, and I'll get into that now. But it was something that I certainly was not interested in doing, because I like to, sit at home and work on my own little problems. But it's daunting, but it's definitely rewarding. And again, part of this talk is aimed towards if you, at some point in your future, decide that you want to solve a problem that other people face. So here's some practical advice for how to go about doing that. So you can tell 4 mistakes that I made when I started talking to people, because they're the 4 things I said that you should not do. So the first is hand people a paper survey. The second is to assume that you just want to convince investors that your idea is a cool one. It almost seems like that's always what you want to do, but that's not the main reason, I would say. What you really want to do is you want to have a conversation with people. And it's very interesting, I found, that if you want to learn how someone is doing something currently, they're often willing to have a lengthy conversation with you, like even 30 minutes. And it seemed very odd to me that strangers would be willing to talk to you for over half an hour about something. But this is really the way that you learn how people are currently struggling with their problems. And sometimes it helps. You have to guide the conversation a little bit. But after talking to a couple of people, you start getting better at keeping the conversation in line with helping you understand their challenges. OK. Also, I'd recommend this. If you go to talkingtohumans.com, there's a great little PDF with a lot of practical advice. OK, so here are some of the things that some of the patterns I noticed when I was starting to talk to people. So a lot of researchers we talk to say they use Skype and hold up, say they'll draw something on either the chalkboard or a piece of paper and hold it up so the other person can look at it. A lot of people also complained about having to type long expressions in order to get their equation in, especially something like this, which it definitely seems complicated, but if you actually want to type that equation up, it's very complicated, right? And if you're missing a parenthesis somewhere in that expression, then who knows how long it'll take you to find where that missing parenthesis was, right? Definitely distracting when it would be so much quicker to draw it on paper.
He's a mathematician.
Sorry?
Wolfram is a mathematician, not a computer scientist.
Yeah, so I'm sure they're aware of this problem too. But this is generally what people have to do, right? They have to type these. Actually, some of my favorite complaints were and from multiple people talking about how they would be using some educational software and typing in a chat window to the other person, typing an equation, and then on the other side it comes out with some emoticon or something. So
You haven't even gotten to the 4 languages yet.
yeah.
Kanji, hiragana,
Yeah, actually, that's something I wish I understood a bit more, but
Have you talked to anybody in Japan or China?
I've talked to people in the US who do foreign language stuff.
Like at Xerox or IBM or universities or?
Mainly universities. Yeah.
Oh, you should talk to Richard Dasher, a couple of buildings over.
Okay. Yeah, I mean, it's really interesting how like you can talk to people and you start learning the challenges that they're dealing with. I definitely would encourage it, um, especially if you want to. I mean, it's very easy to look at some successful idea or some successful implementation of an idea and think that this person, either they were there at the right place at the right time, or it was really they just figured out the way to do it. But I imagine now whenever I look at these cases that there was probably very well known. There are a couple of reasons why it's not very good for drawing though. So most obviously it usually requires a blunt object on the screen, so you can't write precisely. There's actually an exception to this. You can get some battery-powered styluses that actually have a much finer tip, but I'll get into why those also don't work very well. Another problem you have is confusing the palm with the screen, and then it has a relatively long measurement time. The amount of time it takes to actually figure out the position of something is actually too long. In contrast, there's another piece of technology, the inductive stylus, which is really quite fantastic for writing. And I'm seeing some people nodding their heads here, which is it is great to hear because I've actually learned that most people still are not familiar with this technology. But I'd like to tell a little bit about how this works. So what happens is you need a special board behind the screen that emits a localized electromagnetic wave. And then you have a special stylus that, with a circuit tuned to that wave, that will reflect it back if it's at the right frequency. And so then the board emits a localized wave, and then it switches to try to detect the reflection, and that will allow the board to figure out the proximity of the stylus. So this is used in only a few well-known tablets. So the Microsoft Surface Pro, the Apple iPad Pro with the Apple Pencil, that's what that's all about. And then I have a Samsung device here that has an S Pen. So the S Pen also uses that technology. As I will now show you, this is a lot better for writing detailed expressions. But I would like to actually go over the patent a little bit more. Or this is a patent by Wacom, just explaining how it works again. So here they have an array of coils going from left to right. The height in this diagram is actually the full height of the screen. And then there are about, say, 40 or so coils going from left to right along the screen. They're overlapping. And each individual coil, you can select one, send an alternating current through it. That will emit the electromagnetic wave. Then you stop sending the current. And then that same coil can function as a detector. And then if the stylus is nearby, it reflects it back. Something that I think is quite remarkable about this idea is you can have these, you can have a non-trivial circuit inside the stylus. And that allows you to, say, press a button on the side of the stylus or detect the pressure that the stylus is pressing on the screen. So even without having any battery in the stylus, you can have this, this functional input. OK, so going over the measurement and response. So in this figure here, we have some clock signal A, and then B is a signal that determines whether we're emitting or detecting a response. So you say take A and B, and then you get C. D would be the resonance in the stylus itself. So as you're sending the signal, then the stylus becomes more resonant. And then as you stop sending the signal, then the stylus will emit less back. And then E is measured response from the stylus, and then from there is basically processing signal E. But E is basically what you're trying to measure, and that will give you an idea, the proximity of the stylus to the board, or to the individual coil. And then you do this for a bunch of different coils. So you repeat it a bunch of times, and then you can plot the response over all the coils. and then do some statistics on that, and you can determine approximately where the stylus is located. Actually, I shouldn't say approximately, it's incredibly precise. In this patent, they say that it can take them about 10 milliseconds, and that is fast enough to make a pretty precise, to precisely measure where the stylus has been. Okay, so just to make things a little clearer again, so when you have capacitive touch, you have the measuring device is transparent and on top of the screen. For the inductive stylus, you have the measuring device located behind the screen. Okay, so some drawbacks to the stylus, or to this inductive stylus technology, is that, well, you have to have a special stylus, and you have to have a special detecting board, which must be placed underneath the screen in the tablet. And this, I think, is one of the main challenges to getting this technology widely adopted. If you already got a tablet, or you already have your favorite computer, then either you already have this, or you don't really have a hope of using this behind your screen. It also has a drawback of being a little bit sensitive to noise. So for some products like the Microsoft Surface and the Apple Pencil, they actually have to have some power in the stylus itself. So they can't just rely on emitting and measuring the signal. For other devices that don't, like the Samsung tablet, you notice, for example, the camera is not in the location of the screen for that same kind of reason. So some of the devices will interfere with this measuring technique. But the benefits are that you have a stylus with multiple buttons. You don't have palm rejection issues anymore because your palm doesn't interfere with the signal. And you have very fast measurement time. Okay, so I'm not going to go through all the technologies out there, but there are a number of creative technologies. I didn't want to say that this was exhaustive. Probably one of my favorites is the smart pen that uses the De Bruyne pattern. So this is a pattern that, if you look at some piece of the pattern, it's a long sequence, such that if you know a very small part of the sequence, then you know exactly where you are on the sequence, right? And so someone had a clever idea of putting all these dots on a piece of paper, and then you have a pen with a camera that looks, and then it can just see a couple dots near where the pen is, and then it can tell where the pen is on the paper. So okay, so here is a quick comparison of the main technologies that I just mentioned. So this is using a blunt stylus on a standard capacitive device. Okay, I have the same person writing each of these. So this is using a battery-powered stylus, also with a capacitive touch device. So if I jump back and forth between the two a couple times, you can see that it's possible to write a little bit more precisely, but unfortunately it's still pretty hard to tell what the person was even writing, okay, because they're writing too fast. In contrast, this is what you get if you use an inductive stylus. So it's should be a lot clearer to you. In fact, maybe even hard to tell that this was written on a computer instead of pencil and paper, or pen and paper, unless, of course, you read it, in which case you know that is using an inductive stylus. Okay, so the conclusion from this part of the talk is that there is some great technology out there to help people draw. Personally, I found this incredibly useful when I was in college. I took all of my notes and did all of my homework on an inductive tablet. It was that good, and I basically never had to use paper. And I thought it was quite unfortunate when I saw that most people didn't have access to this technology. So yeah, so here's the conclusion. I would say that a computer is definitely more useful than pen and paper if you have this technology. Okay, and then I couldn't find exactly a quote on this particular technology, but I found a quote. So Albert Einstein said, "I admire the elegance of your method of computation. It must be nice to ride through these fields upon the horse of true mathematics while the likes of us have to make our way laboriously on foot." So the context here, he was talking to Levi Civita about tensor calculus, but I think if you completely take it out of context, then it makes for a great quote for the inductive writing technology. Okay, so now I'd like to switch gears a little bit and tell you about some of my experience developing or working on developing a solution to help more people get their ideas onto their computers. Okay, so again, a little bit of a personal story. I first was exposed to this inductive writing technology in high school. They had a cart of these tablets that they would bring into math class, and then we could all write on them. I thought it was very useful, so I got one for college. And then a little bit after college, I bought this MacBook Air, but really missed having the access to this technology and thought, well, wouldn't it be great if there was some sort of peripheral device that I could just have to sort of complement my laptop? So I couldn't find one for a while. I eventually got an iPad because they were pretty cool, and decided to buy like the stylus with the best reviews online, and thought, maybe this will do the job. It was quite disappointing though. So then I started thinking, okay, well, how difficult would it be to make one of these things? So the first idea that I had was, all right, let's try coming up, how inexpensive could you get an inductive writing tablet to be? Maybe you strip out all the fancy things. Maybe it can't even, say, like, give you a good web browser or something. But what if it's just good enough for doing the drawing, right? That could help with costs. And then maybe you could even come up with a revenue model to help. Maybe you don't make money off of the device itself, but you can still run a sustained business by helping people help each other, right? So you have some sort of tutoring model or something where some student is working on a homework problem, they get stuck and they press a button, and then someone else can sort of interact with them remotely. I thought this would be great. It has the advantage of helping students in some low-income neighborhoods and hard-to-reach areas. And then also it can help minimize distraction, because people now, when they're doing their homework, if they have the internet around and stuff, it can be a bit distracting. So it seemed like definitely a really fun idea to play around with. So I started trying to build one. So there's a Raspberry Pi, inexpensive computer, and then this is the guts of one of these. Inductive boards. So Wacom sells these boards that don't have a screen that you can plug in as a peripheral device, and it's very frustrating not to be able to see what you're drawing when you're drawing on it, but it's very good for if you want to get access to this technology without spending much money. As I said earlier, this technology works through the screen. So you have the detecting board underneath the screen. So you, in theory, can take this board and then just put an ordinary LCD screen on top. And so that actually worked. So okay, so I wrote some software for it as well. Basically, try to take away everything that could be, using up processing power, so you can focus on the writing. And so here's a little video example of the tablet in action. So here I'm squaring an expression, and it's a lot faster, say, to copy that expression than to rewrite it twice. Here's another little video, so showing the ability to, say, add more space at the end of a page. Yeah, so I'd like to talk to you guys a little bit about a project I've been working on to, help people maybe write more easily on their computer. So just to give you an idea of what I'll be covering, I'd like to first introduce the problem of digital writing and talk about some relevant technology that already exists. I'll talk a little bit about my own experience developing a solution, and I'll show you a little bit of what I built. There are a couple reasons why you might be interested. So first of all, I'll be talking about technology. And I understand this is a technology colloquium, so hopefully some of that will be interesting. I'd also like to share my experience with entrepreneurship. It's something that's kind of hard to get a grasp of how it works without hearing a bunch of examples, so maybe I can offer one of those examples to you. And then lastly, since this is generally a pretty technical crowd, maybe some of you are still looking for better ways to draw on your computer. So maybe I can help give you help you make a more well-informed decision. Just a little bit about myself. I just finished my PhD in mathematics at Princeton. I was studying partial differential equations and general relativity. I consider myself a computer enthusiast, probably as many of you guys as well. And I've had a couple technical jobs, a number of hobby projects along the way. But as a disclaimer, I don't necessarily consider myself to be an industry expert in computer science. Yeah.
I believe I missed your name. Oh,
sorry. Yeah, I'm John Stogin. Yeah. And I also wanted to, in the beginning, thank Andy and Dennis for inviting me to come speak. Yeah. OK. All right, so I thought I would start with a quote by Steve Wozniak. I had a TV set and a typewriter, and that made me think a computer should be laid out like a typewriter and a video screen. OK, so I thought for a little bit, what are the ways that a computer has helped us go beyond the typewriter? How does it really improve our process of typing, right? And I sort of split it into 4 categories. So the first, which is to me the most important, is you have the freedom to change what you wrote, right? Once it's down on paper, if you're typing, then it's sort of stuck there. But with computers, you can delete, cut, copy, and paste. You can really iterate with your ideas and just put the raw ideas down and work with them. The computer also allows instant communication. So you have email, chat, et cetera. Live document sharing like Google Docs. It also helps with storage and organization. And it can provide some form of intelligence like spell check. But there are lots of ideas that we have which are not easy to use a typewriter or a computer to express. And so then we might ask the question, is a computer better than pen and paper for expressing those ideas? And if we look at the same 4 categories that I discussed with the computer, there are actually a lot of analogous advantages to being able to use a computer for these. So in terms of changing what you write, if you're trying to solve a difficult problem, you don't want your first question to be, where on the page should I start writing this equation, right? You just want to get the ideas down and then work with them. Additionally, for doing calculations, you often end up rewriting the same things over and over, right? So if you're going from this line to this line, maybe you just move a couple terms around, 2 terms cancel or something. That's a new advantage. For communication, something maybe similar to Google Docs, but for handwriting, storage and organization is more or less the same. Intelligence, I think, is one of the more interesting things. We still don't see much of this, but there is a potential to check for errors in calculations, just like spell check, and then also even to perform calculations based on things that we write. But I leave a question mark up there because for some reason, most people seem to still just be comfortable using pen and paper. They're not really using computers for this. And so this is the way that I like to phrase the problem of digital writing, that we don't use typewriters anymore, but we still use pen and paper. OK, so here's another quote, this time by Steve Jobs. God gave us 10 styluses, let's not invent another. So as you may guess, he's referring to capacitive touch in this case, right? So this I mentioned first because this is probably the most well-known technology for input onto a computer besides, say, a mouse and a keyboard. And definitely, if one were to think of drawing on a tablet, which seems more natural for these types of ideas, then capacitive touch might be the place to start. Just a little bit of background on capacitive touch. So it uses a 2-dimensional array of tiny capacitors on the screen. The presence of a finger affects the mutual capacitance. And this is something that then can be measured and converted into some coordinates. Interestingly enough, it can detect multiple fingers at the same time. It's made popular by the iPhone in 2007. And it's very